Hey everyone, and welcome back to the channel. Today we are diving deep into the world of authentication and authorization in ASP.NET Core using JWTs, JSON Web Tokens. Whether you're just starting out or looking to sharpen your skills, you're in the right place. So grab your favorite beverage and let's get started. Imagine a client wants to access data from a secure API hosted in a server. In this scenario, our ASP.NET application expects a JWT in each request header to verify the user's identity and permissions. But what exactly is a JWT? Think of a JWT as a digital passport. If we pick inside a JWT, we'll find three key parts. Header. This specifies the type of token and the hashing algorithm used. Payload. This carries the claims, which are statements about the user, like their ID, email, and role. These claims are crucial for authentication and authorization. Signature. This ensures the token hasn't been tampered with. It's created using the header, payload, and a secret key. You can visualize and explore JWTs over at JWT.io. It's a handy tool for understanding their structure. So every request to our secure API needs this token in its header. If token is missing or invalid, the authentication system will reject the request, resulting in a 401 unauthorized error. Here is how it works. A client sends a request to the server. ASP.NET's authentication provider steps in and reads the JWT from the request header. It checks if the token is valid and if it was issued by a trusted source, one we've configured. If everything checks out, the authentication process is successful. Next step is authorization. This step verifies if the authenticated user has the necessary permissions to access the requested resource. Does the request have the right claims in their JWT to be allowed? If yes, access is granted. If no, a 403 forbidden exception is thrown. Now let's talk about policy-based access control and how it differs from the more common role-based access control, or RBAC. In role-based access control, a user is assigned roles, and each role determines access permission. For example, an API might be restricted to admin users, meaning only users assigned the admin role can access it. However, this approach requires manually assigning roles to each user, which can be cumbersome as your user base grows. With policy-based access control, instead of assigning roles directly to users, we define policies and associate them with roles. For instance, we create a can-read policy which grants read access to an API. Instead of assigning this policy to individual users, we assign it to roles like admin or member. This way, when a user's role changes, their permission automatically updates without modifying each user's individually. While policy-based access control is slightly more complex, it offers great flexibility and scalability. In this video, we'll focus on implementing policy-based access control to give you that flexibility. That was a high-level overview of JWT authentication. Now let's get our hands dirty and see how to implement policy-based authentication and authorization in ASP.NET Core. You can find the complete source code on my GitHub channel, linked in the description below. Feel free to contribute to the project and give it a star if you find it helpful. First, let's look at the dependency injection class. The first step is to add authentication to our project by calling the add authentication method. We pass a schema name which defaults to JWT by default authentication scheme. Essentially, bearer. This schema name does two things. One, specifies the authentication handler. This is the code that handles the actual authentication logic. Two, defines the configuration. It tells ASP.NET how to configure the authentication process. By calling add JWT bearer, we are using the default authentication handlers and configuration for JWT authentication. We don't need to worry about the low-level details. However, we still need to configure the authentication provider. We can configure the authentication provider by directly passing the required configuration by writing values directly into the token validation parameters. Another approach, which is more suitable, is using the JWT bearer option setup file. Here, I've implemented by post configuration option, injected JWT options using the options pattern. This JWT options class holds all the configurations such as issuer, audience, secret key, and timeout. All these configurations are stored in the app setting JSON file. Storing sensitive information in configuration files promotes separate of concerns and make the application more maintainable. With this configuration, we've successfully set up the authentication part of our application. This makes our application recognize and validate JWT tokens attached to incoming requests. With authentication configured, the next step is to define authorization policies and rules. In the dependency injection file, I have called the add authorization method, which adds all the necessary services for authorization. I've also created two classes, permission authorized handler and permission authorization policy provider, and registered them as singleton. Let's explore what these classes do. The permission authorization policy provider inherits from default authorization policy provider. The purpose of inheriting from this class is to add custom permission names to the authorization process. If we examine the user endpoint file, we are using minimal APIs, so I have used required authorization and passed the custom policy name permissions.Can-Read. This means that during authorization, we need to pass this custom policy to the authorization pipeline. To achieve this, I have created a class called permission requirements, which inherits from authorization requirements and has a permission property. The permission authorization handler class inherits from authorization handler and is invoked after authentication is complete. It's where the authorization logic lives. In the handle requirements async method of permission authorization handler, we have access to all the user's claims. We extract the claims of type constant.claims.permissions and check if the required permission exists in the user's claim. If it does, authorization is successful. Otherwise, for O3, forbidden error is returned. The final piece of the puzzle is creating JWT tokens. In the member endpoints class, the login member method accepts a login command with email and password properties. Upon receiving valid credentials, a JWT token is generated and returned to the user. In the login command handler, we retrieve the user by email address and verify the password using a password hasher class. If the email and password are correct, we generate a JWT token using a JWT provider. The generate JWT token async method creates a list of claims to include in the JWT token, such as user ID, email, and permissions. It retrieves the user's permission from the database using getPermissions async method and adds them to the claim. Finally, it signs the token and creates a new JWT security token. Okie doke, let's fire up the application and see everything in action. I'm going to create a new user by calling create user API from Swagger UI. I'll fill in the details and click on the execute button to create a new user. And as you can see, the response code is 201, which means the API call was successful. This is user's ID, which I'm going to use to retrieve the user from Get User API. I'll pass the ID. Then when I click on the execute, as you can see, it throws an unauthorized exception, which is expected because this API has been secured. Let's take a look at the code again. As you can see here, at the user endpoint, it requires authorization with policy can read. To pass this authentication, I need to log in and get a valid JWT token. I'll enter email and password here at the login API. As you can see, now I have a valid JWT token. If I copy this JWT token and paste it into the JWT.io website, as you can see here, in the payload, I have all the required permissions. Here I have email permissions, which is the most important bit, expiration date and issuer, etc. All these are coming from JWT provider file. If we take a look at this file again, as you can see here, I have created all those claims, and the most important bit is the last one, which I create a new claim called permission, and I just pass all the permissions here. I just have one permission for this user. So that's why we just have one permission here. But you might ask why we have just one permission here and when did I assign this permission? Actually, in the create user command handler, I have assigned the can read permission here by assigning the member role. As I said before, there is a many-to-many relationship between permissions and role. In this case, member role has can read permission. If we take a look at the role configuration class, as you can see, we are seeding the database with default roles. And the same story applies to permission configuration. And in the role permission configuration, as you can see, I'm assigning permissions and role relationships, such as administrator, have, can read permission, etc. So when you create your database for the first time and run the entity framework migration, it has some seed data. So that's why when I assign the role member to the new clients, they can actually have can read permission. In the Swagger, if I click on the authorized button and paste JWT token, and now if I try to get the user again, as you can see, I'm able to retrieve the user from database because now I have a valid JWT token to successfully pass authentication and authorization. And that's a wrap up for today's video. We covered a lot, including what JWT is, a compact and secure way to transfer claims between parties, enabling stateless and scalable authentication. The authentication and authorization process, from user login and token issuer to validating and authorizing requests, implementation in ASP.NET Core, we walked through setting up the project, configuring JWT in the middleware, creating a login endpoint to generate tokens, and securing our API endpoints. I hope you found this demo helpful and you're now more comfortable with implementing JWT in your ASP.NET Core applications. If you have any questions or run into any issues, drop a comment below. Don't forget to like, share, and subscribe for more coding tutorials and tips. Thanks for watching, and I'll see you in the next one.